Okay, first thing, this function, if I draw the inverse in negative pi by 2 to pi by 2, what happens? I'm getting the same value of y, okay, corresponding to this. I'll get this value of y. Similarly, from this side, corresponding to this value of x, I'll get this value of y. This is not a function. I mean, this is a function, but if I need the inverse, then the function has to be a bijection. But this is not a bijection in negative pi by 2 to pi by 2. Cos is a bijection in 0 to pi. And cos goes where secant goes, right? Okay, yeah. Similarly, sine goes where cosecant goes. Okay, and tan and cot, yeah, we'll discuss it when the time is right. I mean, in a few minutes. And let me get rid of this. Because we are talking about inverse functions, look at our y carefully. Y is not the, my bad, y is not the ratio. Sorry. Yeah, on x-axis, we do not have angles. On x-axis, we have the ratio. You need to understand it this way. Okay. On x-axis, this x is the ratio and our y is the angle. So inverse functions take us from ratio to the angle. Ratio is the input, angle is the output. Okay. Now, ratio, sine, what comes to mind? Negative 1 to 1, right? That is the only ratio, the range. So let's just, without thinking much, write 1 and negative 1. So this is the ratio which we can get or which we can input to get an angle. Okay. Now angle, remember, sine is positive in first and second quadrant from 0 to pi. So it is not a bijection in 0 to pi. It is a bijection in negative pi by 2 to pi by 2. So we plot the angles negative pi by 2 and pi by 2. Right? This is very simple. Just try to understand what's happening. The axis is vanishing. That's what's happening. Okay. Now, see, I have explained it already, but again, sine is like this, right? 0 to pi, and then like this, negative pi. This is minus pi by 2 to pi by 2. So this is the portion where sine is a bijection. So this is the angle we would take for inverse function to be defined. Okay. So when the ratio is 0, the angle is what? Ratio is the, what trigonometric functions give us is the ratio, right? So when sine gives us the ratio equal to 0, when angle is 0, that means this point has to be in our range. Okay. Now, when angle is 90, what is the ratio? Sine 90 is 1. That means when ratio is 1, the angle is 90. When the ratio is 1, the angle is 90. And when the ratio is negative 1, the angle is minus pi by 2. Right? So our graph will go like this. Oh, something like this. Yeah, maybe. You get the idea, right? Like this. Okay. And okay, what are the other common ratios we get through sine? What is sine 30? It is 1 by 2. So 1 by 2. So this angle will correspond to pi by 6, which is not even remotely here. So this cannot be the graph. Okay, what is the half of pi by? Okay, my graph is not scaled properly. Yeah, let me make another graph. If this is pi by 2, this is pi by 4, right? If this is pi by 4, then pi by 6 has to be somewhere. Pi by 6 has to be, if this is pi by 4, the middle of this is pi by 8. Pi by 6 has to be somewhere here. So my graph should be like this. Yeah. Okay. This is how the graph looks. Okay, you can check for the accuracy like this. Like even I was confused. I'm glad I took this angle, otherwise I would have given you guys the wrong graph. Okay. So this is sine inverse x. Now let's go to cos inverse x. No, wait. Sine cosecant. Cosecant inverse x. Or okay, for the sake of simplicity, let's do cos inverse x. But then cosecant is related. Okay, without thinking much, we know that the ratio is obviously the ratio, significant ratios are 1 and negative 1. Okay, either the ratios are between them or outside of them, or we get the entire axis in the case of tangent and cotangent, right? Now, cosecant behaves similar to sine, right? So again, negative pi by 2 to pi by 2, just as sine would do. Okay. Now look, what is sine 90? 1. So what will be cosecant 90? Again 1. That means we get the ratio 1 and we get cosecant as 1 when angle is 90. So when cosecant inverse, when the ratio is 1, the angle will be 90, right? So this point is in the range. Similarly, this side, we get the ratio negative 1 when angle is negative pi by 2. Okay. Now what else? What happens when the angle is 0? When sine 0 is, when considering sine 0 is 0. That means cosecant 0 is not defined. That means at angle 0, the range keeps on increasing, but it never reaches 0. It indefinitely keeps on increasing. Okay. Similarly, from here, it keeps on decreasing and decreasing, but never reach 0. Okay. And since it is cosecant inverse, we can forget the ratio between 1 and negative 1. The cosecant function never gives us a ratio between 1 and negative 1. So it's obvious that there would be no angle giving us the ratio corresponding to the ratio negative 1 to 1, right? So in the case of cosecant inverse x, the x-axis, that is y equal to 0, acts as an asymptote. And we draw these lines just to represent that this graph is bounded between these, right? Cosecant inverse is done. Now, now let's do cos inverse x. Again, without thinking at all, I'll plot 1 and -1 because this ratio is certain. Now, considering the angles, look, this is the graph of cos, right? So, in negative pi by 2 to pi by 2, it is not 1 1. It is not a bijection, right? It is a bijection between 0 and pi. So, in this case, our angle lies between 0 and pi. Okay? So, y, the angle lies between 0 and pi. And on x-axis, obviously, we have the ratio here. Okay? Now, cos 0 is 1. That means the angle corresponding to the ratio 1 is 0. That means that this point will be in the range. And when is the ratio -1? Obviously, look, when is the ratio -1? -1 here. Look, sorry, forget this graph. Let me just remove it. Okay, the ratio is 1, sorry, -1 when angle is pi. So ratio is -1 when angle is pi. So this point will also be in our range. Coming to 0, I mean, no, yeah, when x is ratio is 0. When is the ratio 0? Cos 90 is 0. So this point has to be pi by 2. We get the ratio 0 when the angle is 90 degree. Cos 90 is 0. That is why cos inverse of 0 is 90. Right? And now, what about its graph? Will it be like this or will it be like this? That makes a nice flower. Okay. Firstly, see, look at this graph. If this is like this, then inverse will be like this. Okay. But let's find some concrete reasoning. What do we know? We know that cos gives us the ratio half, right? So point half, oh sorry, negative half and half. Just mark it on the graph. Now when is the ratio? When is the cos? Half. Cos is half at 60 degree, right? Cos pi by 6. It's always confusing. I'm more comfortable with 60 90 notation, degree notation. Okay. So cos 60 is pi by 2, which is cos 60 is 1 by 2. Sorry. Cos 60 is 1 by 2 and 60 degree is pi by 3. If this is pi by 2, then pi by 3 is somewhere here, right? It is basically dividing 0 to pi into 3 parts. So somewhere around here. So this point should be here. So this graph has to go like this. Now look, your cos was going like this. So inverse goes like this. Okay. And similar logic applies here. So this is the graph of cos inverse. It is obviously not actually like this. You can go to Desmos and plot whatever graph you want and take a look at how it behaves differently. Okay. Now, yeah, this is cos inverse. Now let's get to secant inverse of x equal to y. Angle By the way, I'm doing very inaccurately. This is not how maths is supposed to be done, but the focus of this lecture is just to make the understanding of inverse trigonometric functions a little bit more clear, and I should shut up. Okay, so x-axis angle, right? My my bad. X is ratio. Okay, without thinking, 1, -1. Again, secant inverse x, same as cos inverse x, from 0 to pi. Okay, when cos is 0, oh, when cos is 1 at angle 0, so what is secant 0? That will also be 1. So this point is in the range. That means this point should also be in the range. Secant of pi is -1. That means secant inverse of -1 is pi, right? Because cos pi is -1. That means 1 upon cos pi is also -1. Cos pi -1. So 1 upon cos pi also -1. That means secant pi is -1. So at pi, the ratio will be -1. Now, when is cos 0? Cos is 0 at pi by 2, right? So this is another point of importance. Cos is 0 at pi by 2. When cos is 0, secant inverse at, sorry, when cos is 0, when cos is 0, 1 by cos will be not defined. That means corresponding to this angle, pi by 2, there is no ratio that exists of secant. Okay, so this will be an asymptote. And since we have established this is an asymptote, and also secant has no ratio lying between this 1 and -1. So this graph will go like this, and this will go like this. Okay, and when we are touching the asymptotes, there's no graph. I mean, there could be, but at least in trigonometry, there is no graph that goes like this to an asymptote. Okay, so you can get that out of your mind if you're thinking. Okay, so this is secant inverse x, right? Thing to notice, because secant theta has no value between 1 and -1, so the graph will be empty between 1 and -1. And similar will be the case with cosecant inverse. Okay, now let's plot tangent and cotangent. I took it at the end because it's tricky. X is the ratio, y is the angle, and it's confusing for me too. I mean, I need to analyze. Whenever I hear the word like memorize, whenever I hear that word related to mathematics, my mind goes blank. I cannot memorize. I can practice and remember and understand, but memorize, I mean, practice can only help me memorize. Okay. Anyway, tan inverse x. Let's define tan theta first. So tan theta is again, okay, 0 pi by 2 pi. Tell me, what is tan 90? Not defined, right? Why? Because cos 90 is 0. Tan 90, because Tan theta is sine theta upon cos theta. Cos theta is 0 at pi by 2. Okay. So tan pi by 2 is not defined. So if we take the interval 0 to pi for tangent, we would get a point where the angle is not even defined. Okay. So for tangent, we take this endpoints negative pi by 2 to pi by 2. Okay. And without thinking anything, 1, negative 1. Angle negative pi by 2 and pi by 2. Sine 0 is 0. Tan 0 is sine 0 upon cos 0. So tan 0 is also 0. That means the ratio is 0 when angle is 0. So this point is in our domain, our range. This point is in our range as well as domain. Okay. Now look at this pi by 2. Tan is not defined at pi by 2 and similarly not defined at negative pi by 2. So let me just, not defined means we will not be getting any ratio at these angles. Okay. And this 0 is obviously a point. And when is the ratio 1? Ratio is 1 when angle is pi by 4. Ratio is 1 and ratio is negative 1 when angle is negative pi by 4. Right? So this point and this point. So our graph is supposed to be like this. Okay. Okay. This is not the actual shape. It will be at this 1 and pi by 4, but for the sake of a valid looking graph, let's forget this. This is a valid point, like 1, wait, 1 comma pi by 4 and negative 1 negative pi by 4. These points lie on the graph, okay, but the graph does not look like it actually is. So graph will be like this, something like this. Okay, this is the tan graph of tangent. Now we know tangent inverse. Okay, now we know the graph of tangent gives us the entire range y-axis. The graph of tangent, okay, between minus pi by 2 and pi by 2, it covers the entire y-axis. If you remember, it is like this. Okay, and when we plot tangent, we have ratios on y-axis. So that means all the real line can be the ratio of the tangent of any angle. Okay, that is what this depicts. Ratio, any ratio, angle between negative pi by 2 and pi by 2. So this is tan inverse x. I think this video has gone too long. Cot inverse x equal to y. X ratio, y angle, without giving any thought, 1 and negative 1. Now let's draw this. And let's remember cot theta is cos theta upon sine theta. Sine theta is 0 when angle is 0 and when angle is pi. So if we take negative pi by 2 to pi by 2, we will get a point where cot is not defined. Okay, but there is no such case if we take this entire 0 to pi interval. So that is what we do. We take 0 to pi for cot inverse x. Okay. Again, at 0 it is not defined, at pi it will be not defined. So that means it will never touch this, and even the x-axis. It will never touch the x-axis, the graph of cot inverse x. Okay, because the ratio is never 0. When the angle is 0, the ratio is just not defined. Okay. Now what happens at pi by 2? At pi by 2, cos 90 is 0, sin 90 is 1. So at pi by 2, remember, cot pi by 2 is 0. When the ratio is 0, the angle is 90 degree. When the ratio is 0, the angle is 90 degree. So negative pi by 2. Okay? Yeah, makes sense. Now in this direction, when is the ratio negative? When we go from sorry, this was plus pi by 2 and this is negative pi by 2. The ratio is negative. See, this is cot. A S T C. Cot is negative here. So the ratio is negative. That means this graph will be like this. My God. I'm sorry for making horrible graphs. Not even remotely close to how the graph is. And here. Yeah. Okay. So this is the graph of cot inverse x. Right? And again, this point will be, don't go by this will be 1 and pi by 4. Okay. Yeah, I'll end this video. It has gone too long. If you still don't understand anything, just ask me in the comments.